Okay, the top is just to remind you that of a property. So if you have your properties from yesterday, it's written in such a confusing way, but it's not really. Natural log of E is 1. Okay, because if I put this in the exponential form, my base is E to the first equals E to the first, right? Mm-hmm. So the natural log of E is 1. That's something you need to add to your properties from yesterday. Because I don't think you had it, did you?
No.
Okay.
So would there be like a problem that would just like have natural log E?
Well, you may at some point have that occur, and you need to remember that it reduces to 1. Mm-hmm. Okay, now at the bottom it says there's 2 derivative rules for natural log. There is 1. Okay, it's one of those things where you have one rule if it's just this case, or if you could remember the other rule and it would cover everything. Does that make sense? Mm-hmm. So don't write anything down for right this second. So if I have, right here, I have the derivative of the natural log of x is 1 over x. Okay? That's what it is. That's just of x. Nothing else. But we could use the more versatile one that actually means something and have the derivative of the natural log of u, meaning anything. Remember, we substituted u in for something. Is 1 over u du dx. So that means the derivative of u, correct? Mm-hmm. In other words, the derivative of u over u. So I would write down that the derivative of the natural log of u equals derivative of u over u. And I love how they tell you that u can't be 0. Why can't u be 0? Because it's in the denominator, right? The chain rule will still apply. The product rule will still apply. The quotient rule will still apply. All those rules will still apply. But it's the derivative of u over u. Now, I'm going to go back and look at the first one. Do not write it down, but I'm going to tell you why it is. Well, if I have x, that would be u, correct? Mm-hmm. Well, what would the derivative of u be? What's the derivative of x?
X derivative.
No, what's the derivative of x? 1.
Oh.
Yes?
Yeah.
And if I have the derivative of u over u, I have 1 over x. So this is just when it happens, it's 1 over x. But to me, do I want to remember 2 rules or 1? 1. Okay, so the derivative of the natural log of 2x. Now when I write these, I will always put parentheses around them, just because you're taking the natural log of 2x, right? So what is u?
2x.
2x. And what is the derivative of u?
2.
2. So for natural log, it's the derivative of u over u. So 2 over 2x. So I still get
Is this where you're going to have to use your property?
no, what do I get? I have 2 over 2x.
1 over x.
1 over x. Okay, now, I figured one of you would yell and scream back here. This 2 is a constant, yes?
Yeah.
Never mind, disregard.
Okay.
Nope.
Do we have to do like plus c's on these?
No, because we're not doing integrals, we're doing derivatives. Wrong direction.
So then what? Okay.
That's it.
Okay.
Okay, another one. Natural log. Derivative of the natural log of, and this is why, it switched on me. This is why I put parentheses. Because this is is it the natural log of x squared, or is it the natural log of x squared plus 1?
I don't know.
It is. We know. It is x squared plus 1.
Okay.
But if it was a natural, it would be completely different if it was the other way, right? So it's important to know what's what.
So then, if natural log wasn't of x squared plus 1, like, would the book write it like, so like, let's say the natural log was,
I would assume they would put parentheses. I would hope. Okay,
Also hope.
so you,
X squared plus 1.
x squared plus 1. And du, right? Du is the same as u prime, is
2x.
2x. So the derivative is just the derivative over, so 2x over
X squared plus 1.
x squared plus 1.
Are we going to learn about how the property is going to do this?
Mm-hmm. Okay, now we've got x times the natural log of x. So that's probably going to be the product rule, yes? Okay, so the product rule was the derivative of the first function times the second plus the derivative of the second times the first, correct? Product rule. And if you have your handy dandy derivative sheet that I've told you to make, you should have product rule on there. And it should say the derivative of the first times the second plus the derivative of the second times the first. Now, if you look in the book, it does the opposite way around, but it doesn't matter because it's plus, right? Doesn't matter. And that way we would keep it the same as the quotient and don't mess it up. Okay, so the first thing is x, right? So what's the derivative of x?
1.
1. So I have 1 natural log of x plus, well, the first thing is x, right?
Yep.
Times, what is the derivative of the natural log of x?
1.
1 over
1 over x.
1 over x. So I get what? Natural log of x plus 1?
Mm-hmm.
Now, is it important to put parentheses around that x? What are we taking the natural log of?
X.
Just the x. So do we need to put it there? Yes. I'm going to tell you the book normally does this. So they don't have to do the parentheses.
What happened to the 1 in front of the natural log x?
1 times anything is itself, yes? 1 times the natural log of x is the natural log of x.
Oh, I thought the 1 was part of it.
No.
Like how it was like 1, like let's say like sine be like 1 sine x. I thought that was like...
It was the derivative of x, so it's 1 times natural log of x.
Yep.
Not too bad, is it?
No, it's pretty hard right now though.
Okay, well, that looks like... What?
Too much work.
I got a function in a function, so what rule do we have to use for a function in a function? The chain.
Yay.
Chain.
Every time it's a change.
Chain. Okay, so chain is the derivative of the outside, right? Times the derivative of the inside.
And then
That's
wouldn't
it.
it be times...
No, it's derivative of the outside times the derivative of the inside. That's it.
That's the chain?
Mm-hmm.
I thought there were like 3 things in that thing.
Mm-mm. Unless there's 3 functions. Okay, so the outside function would be the cubed, yes?
Yes.
So that's going to be 3. Oops, I touched it. So it's going to be 3 natural log of x squared. Yes? That's the outside. And the inside would be
The natural log x.
so the natural log of x. So the derivative of that would be
1 over x.
1 over x. And they actually leave it like that, and that's gross. I write it as 3 over x, the natural log of x squared.
Do you want us to write it the way that you write it?
I don't know. I think it looks better. Like if I had to plug something in, I think I would like it the way I write it. Don't you?
I mean...
Because you've done the work. I mean, I don't... This, to me, is not simplified because you have 3 things multiplied together when you could do 2 of them.
So
Thanks. What do you gotta do next on the next one?
Product? No.
How do we need to rewrite that square root?
Well, x plus
Exponent.
1 to the half.
Okay, so we're gonna have the
Chain rule.
natural log. Yep, we're gonna have the chain rule of x plus 1 to the 1/2, right?
Would the natural log be in there with the parentheses?
Oh,
Like if
wait a
we were doing,
second.
like d over dx and then like the brackets.
Yeah, it would be d over dx, and the bracket would be like this. But no, wait a second. It would be chain if it was on the whole thing, yes?
How do we? Yeah, that's what I was asking. If
Do
the,
you have to do
if
chain and
natural
product?
log was part of that.
So, well, we probably should use our rules, right? What does an exponent do when we have our rules?
Multiplication. No.
It
No, it goes
comes
in
out in front, right?
Yes.
So what we actually have is 1/2 d dx of the natural log of x plus 1, don't we?
Yes.
So can our rules help us out there?
Yeah.
Yeah, big time. Because if not, we would have to have the chain inside the natural log derivative. So, does that make sense what I'm saying? And the icky, right? Icky. We'd have to have a chain and a chain. So now, with this 1/2 is out here, so u is x plus 1, right? And u prime is,
Natural log?
nope,
No, sorry.
1. So we just it's gonna be 1 over x plus 1, right? So I have 1/2 times the derivative over u. And we can write it as 1 over 2 times x plus 1. So our rules can help us out and make it much easier to deal with.
Could you do 2x plus 2?
Hmm?
Could you do 2x plus 2 on the bottom?
Oh, you could, but you normally wouldn't multiply it back in because then you'd factor it back out to make sure it was simplified. I would leave it just like that.
Yeah, Sadie.
Because again, if you're plugging something in, it'd be much easier to add 1 than multiply by 2. Then ready for the next one? Ready? Really?
I mean, we're gonna like have to move on no matter what.
Actually, I'm with Sadie. I think.
Okay.
I need to go get a water drink.
Nope. Okay, let's go. We got it. We're gonna use our properties. That was the hint. Like I warmed you up on the easy one.
What? Quit.
You're gonna miss us.
Find anybody who has a letter of recommendation.
Do you want one of my grad advice?
Yeah, when you
Do
come
you
to
wanna
my
give me
graduation
one?
party,
Okay, let's focus.
have
Let's focus.
tiny chicken tacos.
Okay, are you guys ready? Got it written down.
I guess.
Yeah.
Okay, I don't want to do the quotient with all that mess. Do you?
No, so let's do our property.
Let's do our property. What's our property?
L and A minus L and B.
Okay, so we're gonna have
Sorry.
d dx
It's okay, totally. It's fine.
of the natural log of the numerator, x squared plus 1 squared, right? Minus the natural log of, can I just make this 2x cubed minus 1 to the half? Minus 1 to the 1/2. Okay. Well, the second part's going to be easy to deal with, right? I mean, this pretty much. What about the first one? Can we do something else?
Distribute the x. No,
Mm,
bring the 2 up front.
nope.
No.
What happens when I multiply with logarithms? What do I do? Add. Could I tear that apart and add?
Yeah.
And then I could bring the 2 in front. Okay, so I'm going to have dx. We're just getting this all ready, aren't we? Of the natural log of x plus, because we're multiplication. And Shelby said we can bring this 2 out in front now, can't we?
Yeah.
Yeah? 2 natural log of x squared plus 1 minus, what can we do with a half? Can we bring it out in front too? So 1/2 the natural log of 2x cubed minus 1. So now we just need to take, we're basically going to distribute this in, the derivative, and we're going to take the derivative of that and multiply it by 2, and the derivative of that and multiply it by a half. And then we're going to add, subtract them all together, right?
Right.
Okay, so let's go. Derivative of the natural log of x.
1. 1 over x.
1 over x. Remember, u is x. Derivative of x is 1. So 1 over x. So I'm going to come over here, and the next one, u is what?
U is x squared plus 1.
So I have x squared plus 1, and u prime is
2x.
2x. So I have my half, and it's u prime
That's 2x over x squared.
over x squared plus 1 minus a half. Am I going too fast? And then our next u is what?
2x cubed minus 1.
And u prime is
6x squared.
okay. So then we have
Is 6x
squared over x 2x cubed minus 1. And now I can simplify, right? This 2 right here, this half makes that 3, doesn't it?
Yes.
And this 2 and that 2 would become 4.
Which,
This 2 and that. So they didn't get common denominators. I guess I won't be mean.
yeah.
You could do it. It would just take you some time, right?
Yeah.
I believe in you.
I don't believe it.
I should make you do it.
No.
All you do is multiply
I
each
refuse.
one by the other 2.
I still refuse. You can't make me do this.
Wash them. Wash them. Okay, so it looked really, really bad. But once I applied my things, did it work out better?
No.
Not as bad.
It's still hard, but no, it doesn't look that
Find a derivative.
bad. Yeah, so you find the derivative. No. Only you, though. Okay.
I forgot to.
Can we all work on one on the board?
Actually, this I don't want to do. We're going to do this one tomorrow.
Okay.
Okay, that works.
But could we? So then, like,